Welcome back to Pre-Calc. We're going to continue on with 3.4. And I think I can get this all done in one video. Because what you're going to be given is a graph, and you just have to piece everything together to figure out what the possible equation would be. And the reason why we say possible is depending on what clues you have, or you might stretch it out a little bit more than what you actually need to. I know these graphs are sort of tough to read as well, but the origin is right here on this problem. So as you look at the vertical asymptote, it's shifted to the right one. So it might be to your benefit to write, I'll just write it up here, the vertical asymptotes at x equals 1. Well, think about in your factored form, let's name this f of x. Where do we put vertical asymptotes? Well, we put them in the denominator. So x minus 1. Because remember, it's the opposite, goes in the denominator. And maybe that's not what you start with. Maybe what you start with is that there's a hole at x equals negative 1. Well, where do we put holes? At, let's just do the ordered pair, negative 1, negative 2. So it'd be x plus 1 goes in both top and bottom. Maybe another piece that you're looking at is the fact that, well, if we have a horizontal asymptote at y equals 0, which is what it looks like, then so if you have a horizontal asymptote at y equals 0, that means the degree in the bottom needs to be larger than the degree in the numerator. So from here, maybe you just want to identify that you have the y-intercept as negative 4. Well, how do you get a y-intercept of negative 4? Is if x equals 0, you'd have to think about, so if this is 0, you'd have negative 1 on bottom. And if x is 0 here, you'd have positive 1. Well, 1 over negative 1 would give me negative 1. But if I get a y-intercept of negative 4, I can just multiply it by 4. And that might actually give you the correct y value of this. Because if you plugged in, like if you canceled out your x plus 1s and plugged in negative 1 here, negative 1 minus 1 is negative 2. Well, 4 divided by negative 2 gives you this. So I think this would be a perfect possible answer for this graph. And yeah, let's move on to the next one then. Again, I know these graphs are tough to read. But what you should notice is that right here's your origin. It looks like y equals 2 is supposed to be my horizontal asymptote. It looks like x equals 4 is my vertical asymptote. So vertical asymptote at x equals 4. So it might be worth mentioning. I'm going to write this as g of x. You can name it whatever you want though. That's a non-canceling in the denominator, x minus 4. Now I see the hole right here is at 3, negative 7. So I would say, okay, well, that needs to be a canceling factor. I don't know why I wrote plus 3 though. X minus 3 on top and bottom. Now as far as everything else goes, I'd probably want to identify that this x-intercept, that's a pretty big deal, x-intercept at, it looks like it's about negative 1/2. So I would write that as 2x plus 1. And that goes into the numerator. And that might actually be good enough to answer the rest of our problems. Because if you look at the y-intercept, it looks like it's just a negative value. Well, if you plug in a bunch of zeros into the equation, into your x's, you'd have negative 3 over positive 12. So that's sort of confirmed there. If you were to get this into standard form, you'd have leading coefficients of 2 over 1, which would confirm the horizontal asymptote. The only thing I'm seeing here is I did not follow the directions where it says to write in factored form and standard form. So I should have done that. Both of my answers here are in factored form. So standard form would be foiling it out. So 4x plus 4 on this one, and then what's that? X squared minus 1. And then let's see, I kind of have to move my screen over. Let's make it a little bit smaller. Whoa, not that small. Oh well, let's just write it right here. So standard form would be, foiling it out. 2x squared, let's see, it'd be minus 6x plus 1, so it'd be minus 5x minus 3 over x squared minus 7x plus 12. There we go. So make sure you follow the directions, even though I was not doing that for a while. So you might want to pause the video because I'm about to zoom in quite a bit. And I want to move this back. There we go. So let's see if we can come up with our last two answers. So again, as I'm looking at this, I'll just write smaller. I'm looking at a vertical asymptote at x equals -3, so x plus 3. Remember, it's the opposite. A hole at -2, so x plus 2, which happens on top and bottom. And then I see this x-intercept at x equals 3, so x minus 3. And you can confirm that this is right. If you put in a bunch of zeros, you'd have -6 divided by 6, which gives me -1. If I plugged in -2, and for just these two values, I would have -5 divided by 1. So I get my hole in the right spot. And it looks like that's perfect for your answer. So in standard form, go ahead and FOIL. Minus 3x plus 2x is minus x minus 6 all over, that would be x squared. 3x plus 2x is 5x plus 6. And then the last one, it's okay to have two of things because there's two vertical asymptotes. That just means there's two non-canceling in the denominator, x plus 4 and x minus 3. So because those are both vertical asymptotes, nothing cancels there. And as I'm looking at my x-intercepts, I'm seeing x plus 2 for x equals -2 and x minus 1. And that might be a perfect answer because if you were to plug in a bunch of zeros, you'd have -2 divided by -12, or about 1/6, which is about right there. And then if you look at your horizontal asymptote at y equals 1, well, if you were to multiply that out and get x squared, 2x minus 1x is 1x minus 2, and you divide your leading coefficients is what I'm trying to get at. And you divide your leading coefficients, you get a horizontal asymptote of y equals 1. And name it whatever you want. P of x, k of x. You can name them all f of x for all I care. So here's more practice of factoring things out. Where's the asymptotes? Where's everything? And again, I would encourage you to try this on your own before you just get the answer. The bottom's easy to factor, x plus 3, x plus 1. As I'm looking at this, I would make this plus 3 and minus 1. That way I get 6x minus 1x is 5x. And I kind of did this weird, but my canceling are the x plus 3's. But now I can figure out my vertical asymptote at x equals -1. What's the reasoning? It's the non-canceling factor in the denominator. Whereas the whole, again, I want the x and y coordinate. So the whole would be at -3, and then plug into the simplified. Well, if you plug in -3 here, I get -6 minus 1 is -7. And -3 plus 1 is -2. And I'd be fine if you just like cancel those out or took an eraser to them. But we're looking at positive 7/2, and this is the canceling factor. What's the horizontal asymptote? Well, I wouldn't look at the factored form. I would look at the exponents are the same, so you divide your leading coefficients. So there's a horizontal asymptote at y equals, I think showing the work is good. I'm fine if you write out that your reason is the exponents are the same. You divide your coefficients. So then your 0 is the non-canceling in the numerator. So we're looking at x equals 1/2. And then the domain and range, let's wait to do the domain and range. Because we have enough to just go to the graph and see everything that's going on. X equals 1/2 is your intercept, x-intercept. -3, 7/2. 7/2 is about 3.5, yeah, is your whole. Where's our vertical asymptote? Vertical asymptote at x equals -1. We also have that horizontal asymptote at y equals 2. At no point did they mention the y-intercept, but we could figure out the y-intercept is -3/3, so that's -1. And I think that's enough points to be able to connect the dots. Another math teacher might ask you, might require you to graph like 8 points. I've seen, yep, here it is, using 8 points. I'm not going to get that obnoxious with you guys. I just want to see that you understand the behavior of a rational function. So rational functions have this behavior. And now it's easier to go back and do the domain and range. So the domain, I'll do D for domain, -infinity to -3, union -3 to -1, union -1 to infinity. And now you can actually see the range would be -infinity to the horizontal asymptote, and then from the horizontal asymptote to the whole, which we found out was 7/2, and then from 7/2 up to infinity. By the way, if anybody's curious, what they're talking about is making a table of values. I forgot what they named this function. F of x is picking points on either side of the vertical asymptote, like plugging in -6, -5, -4. You'd skip -3 because there's a hole there, -2. And you can figure out what the y values are. That's what they mean by you can always plug in a table of values. And then on the right side, well, we already know a few of the points. That's what I mean by at some point they kind of get obnoxious with picking values like 0, 1, 2, and 3, and then finding out what those values equal. By the way, if you're allowed to use a graphing calculator, obviously if you're allowed, go ahead and use it. You know, if you have access to the technology and you're allowed to use it, then go ahead and use it to double check things. Some graphing calculators will not show you where the holes are located, so that's why I'm sort of okay with that. So this took me a little bit longer to explain, so I have to stop this video, and I'm going to pick you up on the last example with a new video.